This week we are talking about organizing data and looking at different types of graphs because milestones have so many graphs on them. So this is just to kind of give you some practice on the types of graphs. So you're going to fill in the blanks as we go through. So organizing data. Scientists collect data during experiments to help them understand and explain the results. The data may support or contradict their original hypotheses. Organizing the data helps to more easily interpret and analyze what has been observed. Selecting the best table or graph is important for understanding their results and for communicating results. So now we're going to talk about the different types of graphs you can use to present your data, and we'll use them for different things throughout this week. First one's a data table. So data tables are a means of organizing data into rows and columns. So this is more like if you've ever used Excel or made a table, that's a data table. And this enables you to sort, analyze, and compare data easily. So if you look at this example, you can see we're looking at numbers of donuts sold, the types that were sold, and every day of the week, what was sold. Next up, we have a frequency table. And so frequency tables are just used to display the number of times pieces of data occur in a set, meaning like whatever the time limit you gave, how many times that occurred. So again, we're looking at donuts, how many people ordered those donuts in a set time. Still talking about donuts, we're looking at a bar graph. Bar graphs are ones you guys have probably seen a lot. Bar graphs are used to display data that fits into categories or to track changes over time. So sometimes you'll see it with different years. Sometimes you'll see it like this, where we categorize the types of donuts and how many were sold by the teacher, or bought by the teacher, sorry. Our third type of graph we call a histogram, and histograms are used to display data that fits into a range. The height of the bar tells how many fit into each range. So if you look on the left, which is our y-axis, you're going to notice that you can see the number of students, and then on the x-axis, the number of donuts each one ate. So the higher it goes, the more that were eaten. Another type is a pictograph. A pictograph uses pictures or symbols sometimes to represent an amount of data. They should always include a key, because with this one you're using a picture, and so you have to explain what each picture means. Type of graph that you should be pretty used to seeing is a line graph. So line graphs are used to show data that is in some way connected, like how something changes over time, or like a rate. So again, we're still looking at donuts, but now we're looking at over a set of time. So you can see how it changes from day 1 to day 6. We also have an area graph, which we don't use very often in science, but area graphs are also show data, but the area under the line is filled with a color and can include 2 or more sets of groups on the same graph. We have a scatter plot. These ones we'll see in BrainPop Science sometimes. They use a lot of scatter plots, and they are used to show the relationship between 2 sets of data, or how one value affects the other. So like if we're looking here at students' height and weight, we're seeing how their height and their weight affect one another. Like, is there a correlation or a compare, like something that connects them? Excuse me. A pie graph, which a pie graph should be pretty known to you. Pie graphs are used to show the relative size of data, or what part each category contributes to the whole. And with a pie graph, it always is going to equal 100%. So you can always find the missing piece by just doing math out of 100. So those are our main types of graphs. Now we're just going to look at some things that are important to remember when we're talking about graphs. So when you're using a graph with an x and a y-axis, obviously like something like a circle, or I'm sorry, a pie graph isn't going to have an x and a y-axis. The independent variable, which is the variable that you change or control, is always going to be on the x-axis. So again, that's the one that's along the bottom. Also, always title your graphs with a clear and accurate description of the graph. So your title should tell your viewer what the graph is about. Next, you want to label both of the axes on your graph and make sure that you always include appropriate units of measurement. So if you're putting numbers, you want to make sure you're putting hours, minutes, feet, yards, whatever it is. And finally, make sure that you always provide a key for any symbols or colors that you use in your graph. Otherwise, people won't know what they mean. So as a way of taking a look at the basics of graphs as a review, you guys are going to complete an exit ticket where you are going to go to joinmyquiz.com, or you can also click on the link on here where it says time to get to work, and it should take you there. But it has 16 questions that you're going to answer that are digital task cards, and it is going in the grade book, and these should be complete before you come in tomorrow. If you get finished, you're going to put your notes into your, well, when you get finished, you're going to put your notes into your binder, and you can do any of the early finisher things on our class board, or you can complete any missing work.